Hello, hi guys, welcome back to our instrumentation lecture series. Tonight we are going to have a look to one of our topic, which is piezo material or piezoelectricity. All right, let me open the um, PowerPoint slide for you. Okay, guys, this is piezoelectric effect. All right, we are on lecture 10 on piezoelectric transducer. So we go straight here. So piezoelectric effect is very much discovered in 1880 by Pierre Curie as in quartz crystal. Okay, so it came from the work Piezo, which means to press. Okay, so basically piezoelectric effect is very much referred to the study of how basically potential appear across certain phases of crystal, especially when it is subjected to mechanical pressure. Okay, so the best example of piezo material is our quartz, barium titanate, and tourmaline. All right, so this is the the most popular and common material that you know produces electricity when they are under mechanical pressure. Okay, so basically piezoelectric effect actually explained by the displacement of ion in crystal. Okay, it says here when the crystal is compressed, the ions in each unit cell are displaced, causing the electric polarization of the unit cell. And of course, this one very much explain how basically the piezo material when they experience pressure, when you press or when you decompress, basically you are causing displacement in a very small atomic structure, and that will basically displace the ions. The ions that moves, there are thousand or perhaps million of ions are very much displaced, and when they are displaced, this is the action caused them to move, and when they have movement, basically we can measure some on the surface of the material basically. So this is how the piezo material itself can give you electricity basically because of the ions are moving inside. All right, so quartz crystal here, which is the silicon dioxide, is one of the most stable piezo material. Okay, it says here in the slide, and you can see from the figure down there, they call that you have silicon and oxygen, where silicon carries the positive charge and oxygen is carrying the negative charge basically. So when you are exerting forces on the material, basically you are compressing the material or decompressing the material, and you are forcing the silicon and the oxygen atoms to move around in this place, and this process is basically putting out and giving in electrons to the atoms, and this is where the electricity is coming from, basically from the material. Okay, so this is how piezo material became a sensor. Okay, there is A and the diagram over there. From the A diagram, you have the black boxes over there is a crystal, it's a piezo material. Okay, so you have conductive surface, you have piezo material, you have conductive surface, and when you are putting force from the top and the bottom, basically you can put your multimeter and measure the voltage that comes from the both surfaces of the material. Okay, so this is one of the way to measure the voltage out, which they call longitudinal longitudinal effect, and the other one is transverse effect. You can always look at diagram B when you call that diagram B is basically when you are putting the force in the direction basically, and still you are getting the same, I would say, voltage or electricity coming out from the material. Okay, so you can push this material from any direction. They will give you some electricity coming out. Okay, so how basically this piezo material can be used as a sensor. Okay, if you can refer yourself to the diagram over there, you have three different sensors. You have force sensor, you have pressure sensor, and accelerometer. Basically, those three sensors are constructed using the very same material. Look at the red item. The red material is piezo crystal. The gray is the test structure, and the blue is the housing. Okay, so in each of these cases, you will see that the red or the piezoelectric crystal being structured to receive some kind of compression, to receive pressure, or to receive anything that can compress or decompress the red material. So they are arranged in the different arrangement to form out a different sensor, but they are very basically the same material. The red one is always piezoelectric crystal, but when they are arranged differently, they can become a different sensor. But they are all looking about the same pressure receive or pressure release. All this situation can produce electricity. Okay, so how does this material basically produce electricity? We talked about it just now, but how do we measure the amount of electricity that come out from any material? Because we understand that when we give force to this material, they will produce electricity. But the question is, how much force basically do we give to get some, and to get how many volts, for example. So here they show you the equation that relates the force and the displacement, the x. How much does this the size this thing decrease or increase? Which depend on whether you compress or you decompress the material. Okay, so you have x is over here is the function of 1 over k multiplied by the force, where k is basically the stiffness of the crystal. So normally is this material is very stiff, typically 2 but by 10 to the power of 9 in Newton meter. So this material is very stiff. It's very hard material. So meaning that when you give some certain amount of force, if you put in the force value to the formula, you can basically get displacement out of the calculation. So this could tell you that when you give certain amount of force to the material, you may expect some changes in terms of size of the material. All right, you can always calculate that. Moving forward, piezo material, piezoelectric sensors for measuring pressure, force, and acceleration can be modeled by the second order differential equation. You know about this equation, where all the subparameters here are very well explained down there. And the most important thing for you to see here is the omega, which is very much depending on the frequency. Okay. It is also important because you need to know the application that you want to use. The piezo sensors actually depend on the application that you want to use. The design of the sensor is depending on the application. All right, some application require high frequency vibration or motion, and some application the vibration or motion is very small. So this frequency basically define the construction and the selection of piezo sensors. All right. So we have seen how x, or the displacement, is related to the F, to the force. When we exert certain amount of force, we will be observing certain amount of displacement x changes in size. But where the electricity is coming from? So here in the equation, you will have Q over here, which is the charges, and K of x, which is just now x is 1 over k multiplied by f. So we have x being replaced by 1 over k multiplied by f. So we end up having k, capital K over small k, multiplied by f. So this is something to do with, some kind of k is constant basically. So you have constant with the function of f here. Okay, so this is how you can relate the amount of pressure that you put into the piezo material, and with that amount of pressure, basically you can observe how much they exchange, and when they exchange, basically you can use the constant down there to see how much charges or Q that you are observing. Okay, and then they say here electrical current is proportional to the force F. So the bigger the force, you can observe more current and you can observe more voltage too. Last point there says that this thing does not require any power supply, and the output is typically from 1 to 30 millivolts. So it's very small basically. Okay. So in terms of selection of material, here they say quartz is very much preferred because of these factors. The first one is temperature resistance is very high. It is very rigid, very rigid material, very stiff, highly linear, and of course almost no hysteresis. Okay. The reading is always almost constant, in wide temperature range, and of course talking about the rigidity, they have stress limit of 20,000 psi. Okay, so it is a very robust material and very robust and stable basically. All right, so because it's about combustion, internal combustion engine, where you can put pressure material, you can put piezo material to sense the pressure in the combustion chamber basically, because the piezo material or piezo sensor is very robust. They can withstand a very high pressure and high temperature too, and very stable and very linear. So in this application, there should be no problem, because especially when we're talking about internal combustion engine, we're talking about explosion and a very small confined space. So the sensor can take care of this information from the combustion engine. All right, so this is the pros and cons basically. First point is having a high stiffness value, high output with very little strain. Okay, so this thing basically, when you give even a large amount of pressure, the size will not change much. So can basically support a very large, what they call that, load, and maintain the size basically. All right, so it's good for rugged use. For example, just now in the application of internal combustion engine, excellent linearity. Of course, it's ideal for continuous online condition monitoring. The reading is very stable, almost no hysteresis, Next, it can be used for dynamic pressure sensing. Case of okay, it is good to measure if we keep on changing, always changing. If you use it to measure like a very long static condition, it is not very good. Okay, the operation over long cable, effect frequency response. Okay, we have seen just now from the second order differential equation, this thing depending very much on the frequency, and frequency over long cable is not very good. All right, the sensor itself is good basically. Okay, so we are looking at the piezoelectric effect. You have two types. First one is the direct effect, and then you have the converse effect. Okay, for the direct effect, basically you are talking about whether you are giving tension or compression. Okay, the most left is when there is no force is being given to the piezo material, the box down there. So you can observe the voltage output is 0. Okay, then if you look at the middle diagram, if you are, you pull the thing, you are putting the piezo material under tension. You can see you have voltage coming out. Take note on the polarity plus and minus. Okay, when you refer to the last figure, you are putting, you are compressing the material. They will produce electricity. Take note on the polarity. Okay, you have just now when you give tension, you have positive on the up on the top, you have negative at the bottom. But when you give compression to the material, you are reversing the electricity. Okay, so this is the direct piezo effect. This one is the converse. Converse meaning that if you give 0 voltage, you can basically observe the size of the piezo material. Okay, moving on to the middle diagram. If you give electricity, okay, with that polarity, okay, you can see that the piezo material is expanding. Okay, and then the last, the most right box, if you reverse the polarity, the piezo material will shrinking basically. So you can, this is the converse effect. So you have to basically memorize or understand this effect. All right, so for piezo material, it is important for you to understand that if you compress the material, they will give you electricity. Okay, if you compress or if you give tension, okay, you pull or you push, you are getting electricity. But when you give electricity, basically the material itself will expand or contract depending on the polarity that you are giving. So it works both ways. Okay. So sensor and actuator. So piezo material is basically one of the material that can become a sensor and actuator at the same time. Okay, so you can basically recall some material can be used just as a sensor. Okay, and some of the different material can be used as a transducer, as an actuator, but not both sensor and actuator at the same time. Okay, there's different for piezoelectric material. They can become sensor and they can become actuator at the same time. Take for example the microphone and the speaker. You can basically see some of the microphones, the sensors is made of piezo material. Okay, meaning that when you speak to the microphone, you are speaking to the piezo material. Basically your voice delivers some kind of energy that compress and decompress the piezo material. From there, you will have electricity coming out as a voice signal coming to your amplifier, and you will hear your voice coming out from the speaker on the other side. All right, and the same material, the same piezo material also are being used in a speaker. Okay, so you know, when you give electricity to the speaker, you are getting some kind of vibration. That vibration is basically the effect of converse piezo effect. Basically, when you give electricity from this polarity, the piezo material will expand. When you change the polarity, the piezoelectric will contract, and this expand and contract activity is basically vibrating the diaphragm on the speaker, and from that vibration of the diaphragm, basically you are getting some sound from the speaker. So this is how you get sound. This is how you use piezo material as a speaker. Just now I mentioned in one of the example, and now as a speaker. Okay, so here they say piezo actuators here convert electrical energy to mechanical energy, for example speaker. Piezo sensors convert mechanical energy into electrical energy, for example microphone. Okay, I'll skip this one. We talk about this microphone and speaker thing. This is just browsing through some application. In this case, accelerometer. So accelerometer is basically a sensor that measure vibration and motion. So they use piezo material to see how much or what kind of frequency the device is experiencing in terms of vibration. All right, so accelerometer is almost everywhere now, in your phones, in your car, in almost all mechanical, all electronic devices. They have accelerometer, because accelerometer can tell them whether the device is flipping that way, flipping the other way, and they can track motions, and that motion tracking can become some information. Okay, then other than that, you have blood pressure sensor. Also, we are talking about pressure. Previously from the previous slide, that this piece of material, when you compress or decompress, they will produce some electricity. So in this case, blood pressure sensor will basically compress and decompress the piece of material. So this is where you get the signal for the application. So this is impact sensor. Okay, piezoelectric motors also use piezo material, piezoelectric drill. Okay, so that's very much summarized the chapter on the piezoelectric. We talk about how that piece of material can produce electricity. We've seen a couple of formulation trying to relate the force and the displacement and the amount of charge of each any particular piece of material can produce, basically. And then we are looking at some piezoelectric effect. You have converse and you have direct, and from there we are looking at some application of these piezo materials. All right, so hopefully you can clear up some understanding on the piezo material effect. All right, okay guys, thank you basically for now. All right, I'll see you again in the next lecture. Bye bye.